All right, so now we're going to talk about doing a W substitution before doing our U substitution. So remember when we did sine and cosine combinations, and when they were combinations of even and odd powers or just odd powers, we would peel off and make a good DU. Remember, start making the good DU, and these are the two good DU. When we would use this identity because we were leaving even powers. So this is example 1 from the section where we first learned this. So this is pretty straightforward. Peel off a cosine, make a U equal to the sine, rewrite using our identity. Okay, so this one all good and done. So now what my new example 1 is, oh, look, I've got a 4x here. So I could do all of this carrying the 4x angle along, but what I'm going to suggest is you do a W substitution in the beginning. So if I do a W equal 4x, the derivative is just 4dx, so I get 1/4 dw is dx. Now I put the 1/4 on the outside. Everything's in W's. Oops, this should be a cubed. Oops, typo, right? This should be a cubed. So all I've done is just change the 4x to a W. Now I can break up my cosine cubed to cosine squared cosine. Then I can go do my U substitution. So I'm keeping it as my U substitution. So my du is cosine W dw, U is sine a W, and you know that this identity works no matter as long as these angles are the same. So I could go through the same process, right? Put cosine W dw in as du, right? There it is. And then I change cosine squared W to 1 minus sine squared. And then I put the U in for the sine, take the antiderivative of 1 and get U, and then antiderivative of U squared, U cubed over 3, and then finally put the U with the W back in. So I did them both at the same time. Okay, so this was our example 2. We did previous. So I want to leave even powers, so that's why I took one of the cosine squareds and pulled it off. And that's my cosine of x dx is my du, so my u is sine. And I'm going to use this substitution, right, to change everything that's not a sine into a sine. So my cosine squared, I'm going to replace with 1 minus sine squared and go forward with my u substitution. And then multiply it out and take the antiderivative, all good. Okay, so now I'm looking at this, and I've got the angle 3x inside of both of them. So that's what I'm going to let W equal to make the angles nicer. So dW is 3dx, so I get a 1/3, and I have W's. And I'm beginning the process to peel off the cosine dw, and I go through the same process. So you can see here the u substitution stays the same, the antiderivative stays the same, and then when I'm finally plugging back the u in, which is sine of w, I put the w in at the end. So it's your job just to notice, oh, there's little glitchy angles. Might be a good idea to do a w substitution initially. So let's just do this one here. So sine cubed, reminding ourselves we would peel off a sine of x. And this is the one, if I have a sine of x dx as my du, my u is going to be cosine. And so this is what I call the negative issue. In case you needed to be reminded, negative issue. So I'm going to let u equal cosine. The derivative is negative sine, and I'm pulling the negative on the outside. So I want u equal cosine to work. So sine squared is going to be replaced with 1 minus cosine squared. So I get everything in cosines. So I'll have 1 minus u squared, and then sine x dx will get replaced with a negative du. So I'll pull the negative on the outside. So I just have 1 minus u squared in here. Antiderivative of 1 is u, since I've taken the antiderivative with respect to u. Antiderivative of u squared is u cubed over 3. Put the x's back in. I'm done. Okay, so this one here, you're comfortable with this. This one here, I notice there's a 5x in the angle. So let's do a w substitution with the 5x. So dw is 5dx. So 1/5 dw is dx. So I get 1/5 sine cubed of w dw. Then I go through the same process. Peel off a sine. That's my du. And then change this to cosines, 1 minus cosine squared, right? So I've got du is equal to, negative du is equal to sine w dw. I guess I didn't write it down. And u is cosine w, right? So u is cosine w. That's how I get 1 minus w squared. Sine w dw gets replaced with negative du. Same process, except I've got a 1/5 on the front, so I pulled this negative out in the front, took the antiderivative, and then put the u's back in, and then I put the w's back in. All right, so this one here is the old example, tan secant combo. So they're both to odd powers. So I peeled off a secant and a tangent to make the good du of secant tangent, and my u was secant. So I want everything in terms of secants. That'll be good. That'll be good. So this needs to be changed. So I know secant squared is tangent squared plus 1. So I take so that's the identity I'm working with. Sorry about that. And I want to solve for tangent squared because I want to get rid of tangent squared. So tangent squared will be secant squared minus 1. Carry this secant squared along, carry this along. Now it's time to use my u substitution. So this is u squared minus 1. This is u squared. And then secant x tangent x dx gets replaced with just a du. Multiply it out first, then take the antiderivative, then put the x's back in. Okay, so one last part here. So if I see I've got this multiple angle, let's let w equal 6x. So dw is, oh dear, what happened here? Nope, dw is 6dx. And then I'm going to multiply 1/6 dw is dx. So then 1/6 dw is dx. And so then carrying everything else along. So I can see I'm going to have a peeling off a secant and a tangent. It's tangent squared, secant squared. So my u is secant. So again, those two will be taken care of, because my secant tangent will get rid of this, right? That'll be my du. So then go through the same process of substituting in. So you can see this is this, except for the 1/6 on the outside. Multiply it out, take the antiderivative, and put the information back in. Oops, and I forgot the last step of putting in the 6x. Secant cubed 6x plus c.